So now that you've got your flight controller all wired up and installed in your plane, it's time to go into INAV to configure it to get it ready to fly. So load up your INAV configurator, connect your USB cable to your flight controller, wait for the COM to show up, and click connect. And now you are connected to INAV. Now we've already been through the calibration step, so we don't have to do that. That's all set up. That's a one-time thing. We did that before installing the flight controller into the airplane. So now let's move on to the next tab here, which is the mixer tab. Now I'm going to just step through each of these tabs one by one. I don't know if I'll do it all in one video or make separate videos, but we'll just go through here one at a time. So this mixer tab here is where you will set up your configuration for your servos and your ESCs. Now, in a previous video, I selected by default, when I first connected to INAV, there was a window that popped up to select some default options, and I selected an airplane without a tail. But in this case, I've selected an airplane with a tail because I am configuring a Zod Talon GT Rebel airplane, which is a V-tail airplane. So by default, I have selected airplane with tail, which defines this setting to airplane, and I need to change that, because I'm going to go with an airplane V-tail using a single servo for the aileron. So this is the option I want to select. Now, since I've changed this, I now have to click load and apply, and it'll prompt me here to reboot. So I'll save and reboot, and that'll take a moment to come up. And now this should display a configuration that is appropriate for this Talon GT Rebel airplane. Now what we see here in this diagram is some port numbers here, S1, S3, S4, and S5. And they correspond to the outputs on your flight controller. So there's S3, S4, S5, S6 on the outputs there, and you can see up here there's 7, 8, 9, 10, 11. But these 3, 4, 5, and 6 are the ones that I'm going to be using for this airplane. Actually, I'm only going to be using 3, 4, and 5 for the airplane, but I have a pan mechanism for a camera that I'm going to use on S6. But these numbers here correspond to the pins on the flight controllers of the same labels. So what you see down here in this table across the top are these same S numbers, and they go from S1 through S11. And it's showing that S1 is dedicated to a motor, S2 isn't defined for anything, S3 and S4 and S5 are connected to servos. So there's some color coding here that refers to timers that are just peripherals inside the microcontroller that drive some timing operations. And these S output pins are driven by a timer in the microcontroller. You can see that these are grouped by different timers. This is a new feature in INAV 7, and I'm not sure what it's for. I haven't played with it or looked at it. I don't know if it's anything that I need to even be concerned about. But you can see that there is a timer that drives these two outputs. There's a timer that drives these two outputs. And there's a timer that drives these four outputs. So they're kind of grouped together, and I believe that's a hardware assignment. So these, I believe, cannot be changed. But we don't really need to be concerned about these timers. So let's ignore that for now and just look at the associations here. So S3 is driving both ailerons, since I had a single servo for ailerons. S4 is driving the left rudder vator, and S5 is driving the right rudder vator. So these three servos are assigned to pins S3, S4, and S5 respectively. It would be nice if we could go in here and label these. Instead of servo 1, I call it aileron, servo 2, left rudder vator, right rudder vator. But we're stuck with these hard-coded designations. There's a number of things I would like to change in the user interface here if I was an INAV developer, and maybe someday I will be. But if you come down here, you can see there's another table here with these servo numbers here. So these numbers here correspond to the servo numbers here, not the S numbers. So servo 1 is our aileron servo, and this is associated with stabilized roll by default. So this is configured for you. This is kind of a convenient setup that INAV has provided, so we don't have to do this ourselves. It has created these 5 entries. This servo drives both pitch and yaw, and this servo drives both pitch and yaw, but one's on the left and one's on the right. And these individual servos can be mapped to various things that we'll look at as we get a little deeper into INAV. But this is the aileron servo, and what this weight here is telling me is that 100% of the control stick is associated with this operation. And I happen to know for this particular model, this needs to be a minus 100. That is equivalent to reversing the servo. Whether it's positive or negative, you're reversing the servo one direction or the other. Now, there is another option that we'll see later on where you can reverse the servos, and I don't know what the rationale is for using this one versus that one, but there are two places where you can reverse the servo operations. I'm just doing it here, and I also know that the pitch needs to be negative here and positive here, and then the yaw is negative and negative. I'm not sure why that is, but it works, so I'm going with it. And I also mentioned that I am going to be using the S6 line for a pan servo. So what I want to do here is I want to add a new mixer rule. And in my transmitter, I have routed the pan function to channel 12. So there's 12 channels that I can send to the flight controller over a Crossfire. I'm using a Crossfire receiver. So I have assigned that to channel 12. So now after clicking add new mixer rule, you can see that a servo 4 has appeared up here in the S6 slot. Whenever you add a new rule, it adds a new servo sequentially in line here. You can't skip one. So it's going to always add one to the next pin in order. So I couldn't like hook it up to S8 or S9 and use it from there. I could, there's a way to do that, but that's something we can look at later. It's not pretty. But as I said, I've mapped it to channel 12, so I want to pick up channel 12 to drive this servo. Now, INAV has associated roll, pitch, and yaw with those respective sticks. So channel 1, 2, and 3 are involved in here somehow. Or 1, 2, and 4. Channel 3 is the throttle. So that's all hardwired through, maybe not hardwired, but INAV understands that whatever stick you're using for roll is associated with stabilized roll, pitch, yaw, etc. So now that I have added this channel here and I've set up my configuration, later on we can look at the receiver tab here and get our receiver working so we can actually test the direction of the servos to make sure that they're correct, and if they're not, we can come in here and reverse them. So now this is all set up, I can just do save and reboot. And once it comes back, I'll just review it once more just to make sure that everything's the way I want it. And this will wrap up this mixer tab for the time being. Now we can move on to the outputs tab. And don't forget to disconnect.